Hi guys, after like 2 videos back to back about Module 13, one, I want to say thank you for 50 subs, it truly means a lot to me. And two, I did make a few mistakes in Module 13. I did not make it clear, and so I pinned someone's comment that accurately explains it, so I apologize for that. And I'm gonna take some time with this video just to explain it correctly. And number three, I'm just gonna go over my mistakes. And I truly apologize for any question that I might have, well, any confusion that I might have made, because over in the 13, here, if we go here at 13, my mistake was making it n total, which is incorrect. And it's supposed to be p plus 1 times p times n total. And by the time you're watching this, you already must have submitted module 13. So I do apologize for that. And yeah, I don't know what much to say. Module 14 may have like 8 questions, but as immediately when you know what you're doing, it won't overwhelm you. At least 5 out of the 8 questions won't. So, yeah. I gave the wrong formula for Module 13. I was being lazy and I solely used the Excel to sort of deliver my explanation, and that's what ended up confusing a lot of people. I did sort of cheat and use the Excel, but that's because I was running short of time and I didn't launch it in time, so that's probably why. So I'm going to take the time to do Module 14 and probably release it a little earlier than expected because the turn test is coming around the 30th. It's around here. Oh wow, literally within a week. So yeah. Before we continue, always read the question carefully because sometimes it just likes to fuck with you. So let's get started right away. So first off, this is the pain drug test. It'll give you a drug like, I think it's TDH, and then it's something to do with like rash or like skin healing. I don't remember the question exactly, but yeah, it's 4 treatments or 4 groups. 1 measure per participant, continuous single factor, between experimentally defined, because they go through like different treatments, like such as like one is given a specific dosage, another one's given a different dosage. You get the idea. Different levels, quantity is same. It has a linear line, which we'll get to in a second. However, there's a variance in each cell, so this is no. We reject this specific one by saying no, like is this what? Same variance in each cell? We say no, and the question immediately ends here because there's some rate that are harmful effects of the drug. So let's just say it varies from question to question, because I got in both cases where it's like the wound won't heal because of the medicine, and then some people just rate the medicine just being more painful than other participants would, despite giving similar results. And we can see this sort of bias sort of here in the beer group from module 13, where it's like all the 5s and just 1 4 and 1 2. So you can see like a bias. You can see like a major bias in group 1. Just, oh my god, yeah, you can see exactly what happened. And so that's why we're saying, that's why it's getting rejected for same variance here. And I want to point the same thing out for marijuana mood. I basically named it marijuana mood, but basically they're asking like, how do you all feel after taking some marijuana? No joke. I think that's what the question was asking. And yeah, it is five treatments, or like 5 groups. 1 measure per participant, so that's going to be like P1, 1, P2, 1, something like that. Independent, single factor between participants, experimentally defined, because yeah. And then what? Okay, yeah, let's immediately explain what monotonic is and what we mean by this. So below you already saw the graphs, and you see like these graphs trying to explain what monotonic is and linear is. The monotonic is essentially the sense that as the x continues to increase, the y either increases or decreases in a linear or monotonic fashion. They call it monotonic, but essentially if it looks like a log function or like an ex function, this is what they're talking about. And so you will from time to time see a parabola, and that is neither of the two, and I think the question may end there, but I'm not too sure where. I don't remember that part specifically. We'll see further down as we go with the questions. So we'll try playing a game here. We'll see which one is linear, which one's monotonic, and which one is none of the above, okay? So here are like 3 graphs you can see right here, okay? So this one you could say random, but the module will accept this as linear because I can draw a straight line. That's not a straight line, but you see like a line going straight down. They all sort of generally agree. Probably see data points going further down if we were to extrapolate it. So this one I would argue as linear, okay? So if you get a graph like this, I say it's linear. And then for the second one, it's a dead easy one. This is like the perfect linear. Like this perfect example of linear. And this is a perfect example of not being monotonic and not being linear. Like, you can try drawing a straight line, but what the heck is that? That's like a straight A. That's like an A if I've ever seen one. And then you can't say it's like that because it immediately drops like a boat. So this is like a parabola. So this is not monotonic, not linear. They haven't given it a name, so I'm just saying neither to both. I think the question ends here, but come on. Give me the, yeah, there we go. But I've seen it end at other instances. And here's a perfect monotonic example. You will see a graph like this. Yeah, that's the perfect example right here. That's the perfect example for blue. We'll just draw this trend line again. And then for the last one, you can see sort of it grouped up all the way over here. That's kind of cheating, but I still argue that's still a straight line. Okay, ignore me drawing this with the mouse, but I'm doing my best. You can at least see how it's like curving and whatnot. Hang on, this is terrible. You can almost see like the curves and everything that's going on. And if you don't believe me, that I'm giving you the right answer, well, here we go. So for this one, it's correct. This is linear. And then for this one, the answer is no, it's not linear. And then no again, that this is not monotonic. So this is right. This is right. Let me make it green so that, yeah, right. We're not being monotonic, not being thing. This is not linear. However, it is monotonic. So yes, and again, monotonic is like, oh, damn it. It's not linear, but it does follow this trend where it's like x increases, y either increases or decreases. And then, come on. And then for this one, you can see it is linear. And then for the last one, you can see it is linear again. I know it's kind of hard to see that line, but trust me, it's there. This is just to address this one specifically. Okay, now so let's move on to the other questions. So the other one is anxiety on a stats test. I'm kind of being cheeky here. I kind of got bored, and so I'm throwing an inner joke. He's on to us. Okay, so now this is an interesting one because it's like, it'll give us 2 groups where it's like two dependent variables, where one is stress, the other is grades. And then and it's a correlation design. So you're going to be given A, B, and C, correlation. Most of the time correlation. I don't think I've seen an instance of others. I could be wrong. And then so it'll ask, is X continuous? Is Y continuous or binary? Is it independent? Is it not independent? And then we can see linear data. So we've already established it's one of these 2. Or 3 if you go all the way to the third one. And then so ignore this linear data. That's me just basically copy pasting it. So I apologize for any confusion right now itself. But no, it's not linear, so we probably have like a parabola or like we most likely have a parabola because I'm cheating and looking at this because we rejected it here immediately because the monotonic was rejected. So there's no correlation between the 2 groups. So we're trying to find if there's any correlation. So if there's like a linear correlation, then we will continue. If there's a monotonic correlation, I know you can't see it, but it's pretty much like this on the graph. Yeah, so here's the graph. It was pretty much like this. That means there is a relation, but it's not as we expect it to be. So because we don't see either... Sorry for the weird cut, guys, but I found a mistake here, and I don't want to make any more confusion, so I'm just going to continue with this like I already have. So for the problem-solving age one, we wanted to determine whether the kids, like, as we grow older, do we get wiser? Obviously, we want to see whether this is true or not. So we're going to check it out. What makes this one different from the rest is that we don't reject them. We don't reject it because monotonic. Well, we rejected them because they were not monotonic or linear. This one just so happens to be monotonic, and that's exactly what we're doing here. And so let me just... I know I kind of spoiled it and gave the answers away. That's my bad. So, whoopsie daisy. I apologize for that. And so, here's what we're going to do. So I'm going to show you exactly what I'm doing on the calculator here, so there's no confusion created when doing any of these questions. So here in the black, these are all the hard numbers that you cannot change. Okay, so they're always going to remain the same despite whatever may happen. Whatever's in the green is the numbers that are given to you, and the orange is carried forward. Just for this question, let's just go under that premise, okay? So the D here is 12,695. Okay, so let's just figure out the RS first, okay? So let's follow the formula and let's figure out the RS first. So first I'm going to figure out the bottom bit. So I know, I apologize for weird cuts. That's because I made a mistake. I didn't want to show it to avoid any confusion. I know I'm repeating myself like a recorder, but I'm doing this for you guys. Okay, so 99 squared minus 1 times 99. So we just did the bottom part right here. And so we got... Yeah, so actually, you know, I don't need to make the note. You can see already right here what I'm doing. We just did the bottom part right here. Now we're going to do the top bit. So 6 times 6 being the hard number, and it never changes. 12,695. You can see that right here. We get that number. So immediately you know what I'm going to do. This divided by 200. We get this number, and so 1 minus this number. My Control C, Control V is not working. And so we get our final answer, 0.921. So RS is equal to 0.921. And so if I didn't cheat, or if I did this correctly, RS is this. Okay, now what we're going to do is we're going to figure out the t value, because we have determined that we've gone past the point of establishing the null is 0. The research hypothesis says the null is not equal to 0, and we just stated the coefficient, which is the RS. Now we've determined that this is a t-test statistic where the HO is true somehow, and somehow the points is above 12. I'll explain why the points is above 12. I don't get it either, but I have a suspicion, like a conspiracy theory, but that's what I have. So what we're going to do here is we're going to take the RS, which we already know is 0.921, and we're going to divide it by this intermediate, which I call the between, because this is what's happening in between, and we got to make sure we got the in-between correct. So this is our RS, obviously such a big number. So we're going to take this number, and we're going to do the top part first, because we already know what the bottom is. Like 99 minus 2 is 7. I don't need to reiterate that. And the reason it's, again, everything in black, hard. Like, you do not change. Orange gets carried, green is given to you. So, let's continue with this. So let's figure out what we're doing here. Control C does not work. It's not willing to cooperate with me. Control C, Control V, okay. So that's what that is, good. So 1 minus, bracket, Control V, squared. We get this number, okay? So we get this is the top number right here. I'm not going to write that down. And then so we're going to divide that by 97. We divided that by number 97. We're going to square root that. We're going to add 0 so that it doesn't change or anything. And so we get this intermediate number. And so now what we're going to do again, we're going to take the RS, which was 0.921, and we're going to divide that by this special number. Let's copy this. Oh, wait. So let's copy this number. Copy, paste, divided by 0.921. Remember, don't forget that. This in between number. Control C, Control V is... I was having the same issue on module 12. It's 23.37. And now if we go here and erase this, perfect. We can see here that the bottom part, we got exactly that, 0.3943616, because it cuts off here technically and then rounds up. And then we can see that for 2 decimal places, this rounds up, and so we get 23.37. So that's how you do the t. And then obviously here the df alpha 0.05, and then what you would do here is this, and then since it's like 0.0 whatever, this is negative, this is positive, just know that if it doesn't fall in between the range, 23 is way too big, all right? It doesn't fall in between this range, so we immediately reject it. And so this is what we do for the t. And so we're going to do the same thing here with these numbers. And so like I was saying, black is hard, like never changes. Orange carried over, green given to you. So let's do this again. So now we have 70, so 70 squared minus 1 times 70. Okay, get rid of that. And then it's 6 times 6, that's the d squared. That number divided by 342,930. Did I do something wrong here? Hold up. Squared plus 1. Okay. I'm a little suspicious because this... Oh, right, I forgot to square it first. That's why. No, wait, no, I technically did. Wait, what's going on here? 87 times 6. Okay, hold on. Times 70. Okay, 70, because that's the n, squared minus 1, and then multiplied by 70 again. Okay, something suspicious. Oh, wait a second. Oh, no, I just remembered something. 1 minus... Negative numbers are allowed. Negative numbers are allowed. I just remembered that. RS is equal to negative 0.417. Oh, no, I just remembered that. Negative numbers are allowed. Shoot. And so, yeah, that's what we get as the answer. And then so now that's what we're going to do here. We're going to check this out. Oh no. We are in deep trouble, people. Okay, so now that we've established that's the right answer, the negative 471... Oh yeah, I apologize again. I'm doing this module. I've only done it like 2 or 3 times. Usually I do it like 10 times to have like some sort of solid grip and like confidence. This was rushed. This was definitely rushed. Okay, so now we're going to do the in-between part, and we're going to confirm whether the in-between was right, and then it simply becomes that. So this, okay, so we're going to copy, we're going to paste to make sure it works. Okay, it works. Okay, so 1 minus bracket this squared. Enter, what do we get? Ooh, that's a juicy number. And then we're going to divide this by 68 because 70 minus 2 is bad. We get this, we're going to square root, add 0. That's our answer. And then we're going to divide RS by this negative numbers. Okay. So negative RS, which is that number we have established. And then we're going to divide it by this in-between number, which we got to confirm. Okay, why is it 3 decimal places? Whatever, it proves that it's the same. Control C, Control V, enter. Negative 3.78. Let's see if that's the right answer. Boom. Okay, now we know the DF. DF is quite literally n minus 2. I gotta make that more clear. Yeah, DF is n minus 2. So you can see here DF is n minus 2. I'm sorry, I didn't write that down. Ta-da. Okay. Oh wait, I forgot to make it green. Yeah, alright. So DF is n minus 2. And then once we put it, well, this does, we obviously know because this is the lowest amount. This overshoots it. It's a classical reject. So I haven't encountered it except for law, school, or like problem solving, or this. So we'll just leave it at reject. And if it does accept, I think it'll move on. And because we've already rejected it, we're saying there's no correlation. Okay. So we've seen one instance where it does want a monatomic graph. We have seen another instance where it gets rejected because it doesn't follow the sequence. And then we're now seeing a law school money because the thing is not normally distributed like the ranking, because it's wage and clout. Clout being like, yeah, clout being ranking. I put clout and ranking as the same word here. Null is 0, research hypothesis not equal to 0, and t-statistic, exactly why we're doing this. So for law, I don't know why it's like this, but it is not the data is linear. I think it was this one that was the law one. So that's why I said linear data, not normally distributed. Okay, so now we go into the tough ones, and as I think I've mentioned earlier, for this module I'll go from easiest to hardest. So if you've gotten everything from now, this is the easy part. This has been really easy up until now. Now we're going into the nit and gritty, and holy hell, we are about to go. So this is only one half of it, and the equations that follow is just straight up mayhem. Oh boy. Okay. So let's start by saying what we're given and what we're not given. Okay, so we're given that we know that there's two groups. There's the happy group, and then there's the happy group, like people who are happy, and then there's the age group. So do you get happier as you go older, or as like people who are more happier or live much longer, sort of thing. So we know that there are two groups. They're both dependent variables because there's age and happiness. We're recording that. We're seeing that if this is a correlation design, like what is the experimenter into? Actually, I'm kidding. This is just me being dumb. Okay, so this is what the n is. Okay, ignore this party points, no PP part. I'll explain later what this means. And so what's important here is the sigma x, sigma y, sigma x squared, and sigma y squared. Okay, so these parts are all given to you. And also this towards the end as soon as you've completed this part. So when you're given data like this, you're going to be asked all this following. So x is continuous, y is continuous, it's dependent, y is dependent. So we go with linear data. So if it goes to linear data, it won't ask you if it's monotonic. And then if you say like both are linear, well, not linear, normally distributed, this is when you get into this. This is where this begins. So now, yeah, MP is equal to 0, so you gotta do that. So we know that the MP is not question mark 0. It is 0 because we look at age, we are given like 18, not like 18.7. Good luck figuring that out. So it's always gonna be 18, so MP's most like 10 out of 10 times, or like 9 out of 10 times, it's going to be 0. But always check to make sure that it is what it is. So let's do the SSXX, quite literally, but it'll ask for like sum of x or something weird like that. So let's do that right now. So what we're going to do is we're going to take 9131, square it, divided by 227. We get that number, and then we take 393,233 minus this number, and bada bing bada boom. So our answer should be 25942. If we get that answer, there we go. I have it in 2 measurement position. That's wrong. It's supposed to be this, but this is a 2. So we got the right answer. We're happy with that. Now the SSY, pretty much the same thing. So we're just going to do the same thing for Y. Measurement position is 1, so remember that. So this is 18, 128.2 squared divided by 227, the N. We get this number. And then now it's 145,557.57 minus this number. So it's 4,841.1. And that is the right answer. Hooray. Okay. And so now for the XY. Now the formula for this one is pretty much this. And as you're seeing, this is in orange. We're going to have to carry this forward, and this is going to be a real pain. So let's make a note of these numbers right now. So obviously this is going to be as a reference. position, and we're going to leave it as this so that it doesn't... No, I'm going to leave it in the measurement position so it doesn't confuse people. SSXX. Copy. Paste. Except this is YY. We just established 484.1.1. Then XYX equal to... We haven't calculated that, so let's do that right now. So that is U times U, so that's 9313 times 81281.2 divided by 227, which is this big of a number. And then we're going to subtract this with the newly highlighted number. So that's 738,777.9 minus this number. I apologize for that, my alarm just went off. Yeet. Alright. And then we get this as our final answer. Now I don't remember the measurement position, but do check. If it does say to the highest measurement position, it's most likely 1 because you've entered everything in like one measurement position. So read the question carefully and see what it's asking, but I'm pretty sure this is the right answer. So it is in measurement 1 position. So let's keep a note of this. Alright, so now we have these 3 decimal points. Now the next thing it's going to ask is the B cap. And you're probably wondering, how are we going to calculate the B cap? Well, it's pretty much this divided by this. So all we are doing is we're going to take, since I'm also very lazy, I'm just going to do straight up this divided by this 4-2 thing. And we should approximately get the same answer. I think it wants it in like at 0.4, so like 1 measurement position. Let's see if we get the right answer. There we go, we got the right answer. Don't do it the way I just did it. Do it the actual extreme way where it's like what was the previous number? 252. What was that? Yeah. So yeah. Wait. This divided by this, and since the Control-C, Control-V is not working, I don't like it. So yeah, let's just continue. Orange spot, go away. Okay, so that, we got the B right. Now let's do the A. Now the A is a little bit more trickier, but it does require the B. So what's the B cap? So we got the B cap is equal to 0.4. We're going to leave it like that. And so what we're going to literally do is go up here. 13 divided by 227 times 0.4. We're going to remember that number. Okay, and then we're going to do sigma y 282 divided by 227 minus. And so it's okay. I did that. I was a little cheeky. No. This should be the right answer. I think it's 063.8 because of the measurement position. Come on. Well, I want this. What? Oh, okay. I was being a little cheeky and I did that. But had we done had we done the actual thing where it's this? So here, we're gonna do it with that. So copy. See, my Control-C, Control-V is not working. Times this, copy, paste. We get that. And so if we take this, Control-C, Control-V. Oh my gosh. Why is this? Oh my god, come on. Control-C, Control... Okay. You wanna play like that? Come on. No, please. Thank you. Oh my gosh, that was... I'm sorry. There we go. See, that's technically the right answer. I was being cheeky, and that's why we came with 63.77, which is incorrect. 65.01. This is technically the measurement position, but I was being lazy. So, A cap is equal to 63.0. And so now we continue down to the XY. We have this in yellow, meaning that it's going to get carried over. obviously, because we're going to reject this and you're going to see soon why later. This is the formula for it. And using the digits over here. Well, I just realized I am not going to be able to do the formula for all of these, and it's going to take way too long. So, yeah, SSY minus SXY squared divided by X. So this part is done first. And then this, I mean, the control button is not working. If it was so intolerant, then I would have done all of this, but you just saw what happened, so I've given up with the control button. So yeah, you should get the expected answer as this, and then the new expected answer is this. And so, yeah, divided by that and square rooted. And then for the beta, it's 0. Beta null, it's 0. And then for the R value, all you're doing is xy divided by xx times yy square rooted. And then you get an R value of this, and then you put it into the square root, into the t-test to see if it all works. You get 24.9. You got to remember this number because this is important to determine whether you're going to accept or reject. Also, don't forget this. Null is 0. Research hypothesis not equal to 0. And state the coefficient. I forget the coefficient, but this is the coefficient as previously established from the other questions above. And so, yeah, t-statistic is proven to be true. Again, points. I don't know what it means by points. I got cheeky and I just said those were PP points, alright? Those are party points. And party points is 454, way above 12, and that's why we're doing this. And 225 because DF is n minus 2, which was, I'm going to write the n here, 227 minus 2. We get DF, which is this. And then obviously alpha, the alpha. And then you remember this. Way past that, that's a good old reject. And then now we gotta find like the R percentage. And so the R percentage is the SXY, which is the value from above. Don't worry, everything's gonna be here on the left window. Once I get the walkthrough out, squared divided by XXYY times 100 to get the percent. You get this number. Okay, now the XP is given to you. You gotta be careful. It gives it to you. And so the Y cap, or like, yeah, pretty much Y cap divided by XP, quite literally, A cap plus B cap times XP. So 28 times B cap, which was 0.4, where is it? 0.4, and then it's added by this. So you can already imagine what answer it gives you. Oh no. Oh no. Yeah, we just need that. And then this is the standard deviation, so you're taking the SYX here. And then you're putting it in this huge formula. So this is exactly what you're doing for the SD. It was confusing, but this is what you do. You 1 plus 1 over. And the XP 28 minus that, which we got a couple of times. So whatever the difference is, you square divided by SSXX, and then you add this all up, square root the whole thing, multiply it by this, and you get the SD 2.4 because you want it in one decimal place. And then lower boundary in confidence interval is the alpha, so it's pretty much this times this 2.4, so that times that, minus the XP, so you should be getting, if I'm doing this correctly in my head, hang on, we're just going to use the calculator because I don't have to do any Control-C, Control-V, or bullcrap, minus, I usually do the bracket to indicate that this is what I'm doing first, times, 0.7, I already did the negative at the beginning. You can leave it as positive and change the minus to the plus, it's up to you. So that's our expected answer in 2 decimal places. We should get something close. Come on. And there you go. Perfect. And then for the next one, which is quite literally 7.53 plus, and then 2.4 times 0.6. Okay, and then it's just 80. 8.1. I was being lazy here because of the XP. We got lucky here, but yeah. It's technically way bigger, but you will see later why. And so this is one out of the three questions. The second and the third are very similar in terms of content and in terms of rejection. And because we rejected, we had to do these extra steps. Otherwise, it would have just been with this nightmare. But because we rejected, we had to do this entire nightmare. And so we continue down. We see, yeah, I didn't even talk about the question to begin with, did I? Yeah, happiness and age. I think I might have. I don't know. I don't care at this point. Ignore this black part. In fact, this should be red because I was doing a little good old copy paste control just to see what it was like. Okay, so sleeping and feeling. So how do you feel after waking up? So if you got a good rest, how do you feel? If you got a bad rest, how do you feel? So this is pretty much what happened. There were 5 different groups, each measured once, continuous, independent, single factor, between, experimentally defined, different levels, quantitative. It was linear, normally distributed, same variance in each cell, and bada boom. The moment you finish this, you go right here. Now, I just want to quickly note that I know I'm cheating and scrolling all the way down, but you have to check and see if the n is always constant. Where's the thing? If the n is always constant for all groups, and then use the current method listed below. Otherwise, use n total as the new PP. Okay, so come on. Come on. Okay, there we go. So, because we knew... This is the same question? No, we just did this. Okay. Sorry. Okay, so because we know that... Or because I know that there were 4 for all, every single one of them, the PP is 20 points. So, number of groups times n is equal to PP. Or the more accurate one is simply just n total. Okay? Because let's just say, out of nowhere, this is like, I don't know, for some reason, 7. So the new PP would be 16 plus 7, which is... Yeah, I can't do quick math in my head. I think it's 23, but I could be wrong. I'm being PP. I'm being very immature here by using party points. But essentially, this is what's happening. Okay. And so, once you do a question like this, you're given number of groups, you're given n. More specifically, this doesn't really matter, but I have that there. We are given this, this, and this. We're given all these numbers, but you have to add them all up to get the sum here. So let's just go to the calculator real quick. So 253.2 plus 7.4 plus 282.6 plus 283.9 plus 333.5. So as you can see here, it's the sum, and obviously the same thing here. And so now if we continue with the PP as 20, I'm being very immature here, okay? I'm trying to make this more lively than it already is. I'm fully aware I'm saying this in a boring tone, and this is all boring, but just bear with me here as I keep saying PP, all right? If you can't hold in your laughter, don't do anything about it, okay? So we're gonna do the we're gonna do this because calculator is not like cooperating with me. Okay, I thought I could do this, but I can't. I need that. Okay, so we know that this is x squared, x, and the PP is 20, okay? If you still think I'm immature for saying it, I don't blame you. Divided by 20. Ah, that's such a nice number. 600 minus 540.8. I think the measurement precision was 1 for this question. It could be 1. Not sure, but voila. And now to prove to you that the SSY, which is pretty much the same as the SSX, is the same, I'm going to do it right here. 0.6 squared divided by PP. I'm not going to stop saying it. I'm enjoying this way too much. Okay, minus 99,489.681. Okay, so I'm pretty sure the measurement position here was 1, so it's going to be 0.7. And ta-da. Okay, and as we already established xy, we're given it. And so what we're going to do here is 1410.6 times, what is it? 104 divided by pp. It's that. Was I supposed to square it? No. I can get away with by just using the PP alone. Alright. So, I'm not sorry. Okay, 3.6 minus, what is it? 7335.2. So I guess it's 23.8.5. Come on. Ta-da! And then now for the B cap. Okay. Okay, since the numbers were all simple and they were very friendly, we can get away with doing this. And so since the numbers are listed here, all I'm going to do is this. So this is essentially 2 divided by 59.2. Okay, because that's what the B cap is. You're dividing this by this. And as we previously established, this is this number divided by this number. And so for the B cap, it's supposed to be this number, but I think it wants it in plus one measurement position, so it's going to be 4.03. I think I remember the question specifically asking it for one extra. You're going to see the answer just as is. Perfect. Measurement position now is equal to 0. Don't ask me why. It wants it back to this. And so for A, we already know what A is. Okay, please cooperate. Thank you. Okay. So if I do this correctly, we can do this all in one thing. Okay, so this 0.6 divided by PP 20. Again, PP 20, which was 5 times. So that's 5 times 4 there. Plus bracket. Yes, thank you. Thank you, thank you, thank you. Times bracket. Okay, we will have got 104 divided by 20. Bracket. Okay. Hold up, what did you do? Okay, now hopefully everything was done correctly, because I'm really worried that this may not be the right answer. So I'm hoping that the answer is 91. Nope, never mind. Okay, so I can't trust the copy paste thing. Okay. So, okay, let's just... Where did I go wrong, though? Where did I go wrong? Yeah, where did I go wrong? Like, we did everything correctly. Okay, so let's do everything individually. So, let's do the x again. 104, 20, 5.2 times... We saw 20. We saw that 20 thing. So... Okay. Great. Control C. Control V. Okay, perfect. And now... 1014.6 divided by 20. What the heck? 6 divided by 20. Okay, and then we add 20.94932. Okay, it doesn't matter. Okay, wait, then, whoa. What did I do wrong? What did I do wrong? It's supposed to be the same, isn't it? Okay, so... What is this question? Sleeping in. Okay, so then where am I going wrong? Because it's 104 divided by 20 times... Yeah, we multiplied it, and then it's... And where am I... Oh, it's subtracted! Oops. Oh, I've been adding it this entire time. Okay. So, let's just... Okay. So, this is awkward. This usually never happens. Okay, there's the perfect answer. Jeez, I'm such a dumbass. I apologize for being this dumb on screen. Okay. So we now know what the... So now we're going to solve for the SSYX. I don't know why this is in yellow. I thought this would get carried over, but I clearly was wrong. And so let's just do that. Okay, so let's figure this out. So this is given with a graph, so it's like linear and everything, so... Yeah, let's figure that out. So this is the formula. Subtract. Okay. 0.5. Alright. Was the number really that simple? Oh no, it wasn't. 48. Squared divided by. Was the SSX really simple as well? It was like 59 point something. Ah, yay, it was 59.2. That's nice. Okay, so we get that. And then, okay, please, for the love of God, copy paste. Thank you, you're far too SSY. So I think, yeah. Oh, okay. 09. I love the fact that these numbers are so simple, so I can type them out. Okay, if I were a guessing man, I'm pretty sure the MP is either 1, 2, or 3. If it's 3, then this is the correct answer. Yep, it's 3. Okay. Well, no, it's not 3. It's 4. I'm sorry. It's 4. So we got the right answer. Wonderful. Okay, now what do we do? Okay, so now we divide this with the PP minus 2. We divide this by 18. Square root it plus 0 so that we don't fuck this up somehow. And we should get 7.9687. Perfect. So what we did here was we just carried that number over, divided it by the PP minus 2, which is 18, square root it, again, PP, 20, and then square root it all. And then for this last one, okay, that is wrong. That is full on wrong. Copy, paste. There we go. That's our right answer. So if we take our answer from there, save. So, okay, that's my bad again. YX, so this is 7.9687 divided by, man, he can't even do his own formulas correctly. I know, right? Okay, and we divided by this. Come on. We should get a pretty close or similar answer. So, for the most part, it's very similar. And then for calculating YT, so that is b squared minus 0 divided by that number. So it is pretty much, wait, b cap, so 0.43 divided by 1.0357. We're gonna get a pretty similar answer, though I doubt it's that close. I think it's 3.99. Oh no, we got the perfect answer. Fantastic. Okay. So let's continue onwards. And now we established that the b cap is equal to 0. C, b cap is not equal to 0 as the research hypothesis. It's normally distributed. We don't know the standard deviation. And so now we start with the t's. So we ended up rejecting it. Obviously. Because that 3 is bigger than that 2. We ended up rejecting it regardless. And then so we follow the system all over again. And yeah, pretty much it's on, copy, repeat. So this is exactly what you need to do if you reject this given scenario. And yeah, the only exception is to the one above because it doesn't use PP, it uses N differently. And so this is pretty much the same, where it's just PP instead of N. SD, right? Yep, it's pretty much the same. So it's pretty much the same here. And yeah, let's continue over to the last one, which is marijuana space-time sound. So immediately when you see this, you're fucked. Because you gotta do all of this now. Okay? So this is gonna be an extremely long video, I can already imagine. So we know it's 5 treatments, 6 per measure, because you're going to see R1 instead of P1, R2, R3, R4, R5, R6. So it's going to be 6 measure per participant. It's continuous, independent, single factor within participants because everyone's going through the same thing. Randomly defined because everyone's taken and put separately. Different levels for factor quantitative. Still don't know what that means. The module will do its own explanation. Yes, guessing if it's a linear. So you draw a potential line. You get a straight line. It's normally distributed, same variance in each cell. And then immediately after, you continue over here. So ignore this part over here where it's like null is equal to 1. Basically, I had no idea why it was equal to 1. It just was equal to 1, and I suspect it's because of the multiple measures. So yeah, just ignore why it's null. And then yeah, research hypothesis is not equal to 1, normally distributed, and we don't know the standard deviation, and that's when we continue all the way here. And because we accepted it, the question ended here. Unfortunately, there will be another question where it'll make you reject it, and I'll show you. And the formula is pretty much straight up copy repeat. And so we're doing the same thing over and over again, but I want to go through the questions just to be sure, okay? And there was an instance where like this popped up where like the one n was completely different. I thought to get curious and try the n total. N total was definitely the right answer. So instead of PP, you could replace it with n total, but PP is funnier. And I'm always going to refer to it as the PP. Okay, so we got the number of groups as 5, n is 6, PP is 30. It's quicker and easier to refer to. We're given sigma x squared, and sigma y. I did the module like 2 times. These two were pretty similar. Sketch, real sketch. Okay, and then so yeah, we're doing this all on repeat. It was pretty much the same as the above one. Like, I don't see much of a difference, except this one got rejected quickly. This one, there was a rare instance where it got accepted, and so it ended there. And so if you want to, do it all over again and see if you get the same answer. I know this says least squared, but this was because I didn't know what to give it as an answer for. So this is technically a cap. I'll just draw the symbol instead of giving it the thing. I don't know how to do the cap on Excel. Don't at me. I'm a little dweeb. And you can see here that the t-value got accepted in that range. And so if rejected, we're repeating all of this again. Lower boundary confidence interval. Yeah, I'm sorry, I didn't mention this. Yeah, lower boundary confidence interval, so LBCI, upper boundary confidence interval, and so that's exactly what that is. That is it for Module 14, guys. I'm sorry I couldn't go over the second part with you. The calculator, oh man, the walkthrough is going to be a pain in the ass. I'm probably going to do it on Demos thing, just to keep everything like tracky and aware, and probably have everything on a notepad so I know what's going on. And yeah, that is it for Module 14. Let me know if you guys if you're confused with anything, or you want the walkthrough. Walkthrough is going to come either today, tomorrow. Well, definitely not today. Sorry for that. It's either going to come tomorrow or the day after. It just, yeah. These modules are eating a lot out of me, and to everyone that made it this far, I want to say thank you for watching till the end, and good luck on the midterm or on the exam. Just straight up, good luck. You got this, alright? Thank you so much for watching, and I hope you enjoy.